Hey everybody, my name is Tom Tullis. This is the Tomb of 3D Printed Horrors, and today we're going to take a look at the new Creality CR-6. This is a really nice printer. I'm very happy with this. I know Creality had some teething issues with the first batch that went out from the Kickstarter, but from what I have been told by Creality, that's all been resolved now as far as the main boards. My printer was from that batch, and I did not have an issue with the main board on it. I did have an issue with the switch not being it wasn't a positively locking switch when you had it on and off. There was some wiggle to it, and it was very soft. It wouldn't engage fully, so I just swapped that out, but that is supposedly resolved as well now. So if you're buying a CR6 from this point on, when I've released this video, you should not have any issues with either one of those. So what's new on this? Well, the big thing is probably, I think it was last year sometime, Creality did a user survey and wanted to see what people wanted on printers. And the number one far and away thing that people wanted most of all was true auto bed leveling. So Creality, instead of going with something like a BL Touch or an induction sensor like you have on a Prusa, which they are auto bed leveling, and they will create a digital mesh for the software to adjust your first layer printing based on deviations in the build surface. This setup that Creality is using, what you're seeing here on screen, is using a strain gauge. Strain gauges are nothing new. They've been used for seismic measurements for decades. They've been used in kitchen scales. So this is really not super high-tech equipment they're putting in this. It's been around for a very long time. They're very reliable. There's not much to it. It's basically that rectangular steel piece that you see in the upper right hand side just above the Creality logo on the heatsink. And what this is that center lip or tongue has wires on it under that white section. And when that tongue is depressed from strain, those wires deform, and that adjusts the amount of current going through them. So the firmware will sense the deviation in the current flow, and that's how it knows it's touching something, basically. And that's just a very rudimentary way of explaining it, but it's a really novel approach to bed leveling, because instead of having a sensor that detects pieces of metal embedded in the bed, an induction sensor, or a BL Touch where the separate sensor is touching, with the strain gauge, it's your actual print nozzle is what is touching and gauging where the bed is. So that's going to be much more accurate and simple to dial in. So this is a really nice design. It's very cleanly done. The miniature board that runs it is there on the right, the green board. And the added benefit of having this mounted on the moving hot end assembly here on the x-axis is all of your fans and hot end plug into this board. So if your hot end or your cooling fan or your nozzle fan goes out and you have to replace it, you don't have to run all of that wiring down to the main board then. Your replacement piece will actually just plug into this micro board off to the left there. So it's going to make repairs on this much simpler than they otherwise would be, say if you're using an Ender 3 Pro or an Ender 3 V2 or a CR10 or an Ender 5. Having the plugs here is just great for maintenance down the road. It's going to make it much easier for you. So I just wanted to point that out while we were looking at this. Moving on, another change that they've made is they have an all-new feeder assembly for the extruder. I'm mixed on this one. I love the new design. It works phenomenally well. From a mechanical standpoint, it works great. It is an improvement over their previous design. So it does its job, and it does it very well. What I don't like is the fact that it's fully encased. Anybody that's done any amount of 3D printing, you know that eventually your feed gears on your extruder motor eventually fill up with small plastic shavings from the filament. That's just from use and retractions, and it just happens. And you have to get in there with an old toothbrush or something and clean them out periodically. Well, with all of Creality's prior machines and most other 3D printers, the feed teeth are open. There's nothing covering them, so you can get in easily with a toothpick or an old toothbrush and clean them out as needed. With this one, you're going to have to disassemble the extruder, and it's not going to be hard, but it's something I really don't think you really needed to do sealing this in. So that is something to be aware of. It's a nuisance. It's not in any way impacting my judgment on whether this is a good machine to have or not. I think it's a great machine, but it is something to be aware of. You are going to have to take this top cover off and then readjust the filament tension when you put it back together. So it's going to be a little bit of a pain to do, and I think it just irks me because this wasn't necessary. They had a perfect open face design before that was easy for maintenance, and now they went to something that's harder for maintenance. So again, it's a pet peeve on my part. But moving along, they have a storage drawer on this machine. This is really nice because they give you a full set of the Allen wrenches. They give you a 6mm hex wrench, which is great for taking the nozzles off, and your SD card with your firmware and everything is in this drawer as well if you're looking for that. Alright, let's get started on this. There's really not much to do on this machine. It's nowhere near as complex as, say, an Ender 3 or an Ender 5 as far as assembly, because most of it comes pre-assembled. And your wiring there's only a few wiring points on this because they're all combined. So let's take a look here. I'm going to flip this over. Before we get started, let's take the glass bed off. You don't want anything to happen to that while we're working on it for assembly. The first thing you're going to want to do before you assemble this, it's going to be much easier now than later to get your eccentric nuts for your movable print bed adjusted and tuned. You can do it later. It's not that big of a deal, but it's certainly easier to do this now while you can flip just this base unit around. So I'm going to rerun the instructions from my Ender 3 V2 assembly video because everything works exactly the same at this point. Now it's time to talk about eccentric nuts. If you look here on the side, you have a smooth post and on the right, a hexagon post. The hexagon is your eccentric nut. And the way eccentric nuts work is these nuts are off. The post through the center that holds the wheel is off center from the nut. So as you rotate the nut, instead of the wheel spinning in place, the wheel will make an orbit. And this allows you to tighten that wheel up against the rail or loosen it because it's moving in an elliptical fashion. This is a view of the eccentric nut taken off. And as you can see here, the post for the wheel is offset to the left. So as you turn the nut, the wheel is going to spin and make an orbit. And if you look at this illustration, here's a wheel. The eccentric nut is in yellow. The wheel is against the rail. And as you turn the eccentric nut, the wheel will make an orbit and actually move away from the rail. Once you get to the furthest point, it'll actually start moving closer to the rail if you keep turning in the same direction. So at this point, we need to adjust the eccentric nuts on the bed before we go any further. There are two eccentric nuts, and they are the ones that are hexagon shaped. If you're looking at two that are perfectly smooth posts, you're on the wrong side. Now, the way you adjust an eccentric nut is you're going to use your wrench and move it in very small increments. You should feel it loosen up. The ideal tightness for these wheels is enough that whatever it is that they're moving, in this case it's the bed, does not wobble. You don't have any jiggle to it. But you do not want the wheels so tight that you cannot spin them with two fingers with effort. They should not freely spin, that would be too loose. But you should be able to hold the bed in place and just barely be able to turn the wheels with two fingers without the bed moving. If you can do that and the bed does not wiggle, you've got your eccentric nuts perfect. Okay, now that the eccentric nuts are tuned, I notice my bed is still wobbling. And the reason for that is the screws that are going through the aluminum plate holding it to the carriage are actually loose. All these screws are like a half turn to a full turn loose, and that's allowing that upper aluminum plate to shift. So it's going to be really easy if you don't catch this to think you don't have your eccentric nuts tuned and over tighten them thinking that's where the wobbling's coming from. If you have your eccentric nuts tuned the way I just described to you a moment ago, your problem is this plate. Go through and tighten all of those screws up. Okay, so to get started, I really strongly recommend using one of the foam inserts that came with the machine in the box to build your printer on. This keeps you from scratching anything up, your printer or your table. To get started, we're going to flip this over here and put the uprights on. Now, this entire assembly comes pre-assembled from Creality. All you've got to do is put 4 screws in the bottom. When doing this, these are your M5 by 45s. And what you want to do is get all of them worked in by hand. Do a few turns on each one, but don't do one full screw and tighten it all the way. Get these all worked in most of the way and then go through and tighten them. There are milled recesses in the base horizontal extrusions, so this fits nice. It just drops right into place. You don't have to worry about alignment or anything like you do on an Ender 3. So get that done. Next up, we're going to put the LCD touchscreen on. This is your M5 by 10 screws, and those just bolt on the front. There's 2 of them. Next up, we're going to put the spool holder on, and this just rocks into place on the horizontal extrusion on the base. Put it in front of the uprights and just maybe a ½ inch or an inch in front of it. This will rotate out of the way when not needed. Next up, we're going to put the carry handle on. This is done with M5 by 10 nuts, or M5 by 10 screws and M5T nuts. The T nuts go horizontal, and you barely want that screw inserted into the nut. You want that nut as far away from the handle as possible, like I'm showing you here. And what that's going to do is allow it to drop into the channel on the crossbeam at the top. If that nut is too tight, it won't drop below the lip on the crossbeam in that channel, and it won't tighten properly. So once you get that in place, go ahead and tighten them up. What those T-nuts do is they rotate 90 degrees once they're in the slot and then self-tighten themselves. Or self-align as you tighten them, sorry. Alright, that's it for actual physical assembly of the printer. There's really not much to it. Next up, we're going to hook up the wiring. To start with, we'll look at the LCD screen. The wiring for that is taped right beside it on the main bottom part of the printer. Just plug that in underneath. There is a single port for this now, unlike the Ender 3 that had 3 different ports and you had to make sure you got it in the right one. Next up is the 2 Z-axis motors for the screws. The wiring is right next to each motor, so you can't get that messed up. It's the only wiring that will reach it. So there's the one for the left side and the one for the right. Okay, next up is the sensor for the bed leveling. What this sensor does is, when you run the bed leveling script, this sensor will trip as the nozzle approaches the bed, and it tells the machine to start looking for sensor data from that strain gauge. And it's just a little slot. There's a little bar that's on the movable x-axis that moves down. When that bar moves into the slot, it trips the sensor, and then the machine knows that the nozzle is approaching the bed and to start looking for that leveling data. So that just plugs in like that there. Next up, we have the wiring cable. This is going to plug in just behind the X-axis motor and below the extruder motor. And this is your hookup for both of those motors and your X-stop axis and your extruder and the filament runout detector. All of those run through this cable. So very easy to set up. Just plugs in like that. Next up is going to be the cabling for the actual hot end assembly. You want to make sure it runs through this clip on the back of the X-axis just beside the extruder motor there, like this. That'll keep it nice and clean. And that's going to plug into this plug right on top of the movable hot end assembly there. And once you plug that in, rotate those little side arms in place. That'll keep it from getting yanked out. Next up, the clips, the wire clips from Creality. There's 3 of these. Just make sure these are on and keeping the cable and the Bowden tube connected. I really don't recommend zip ties for this because they are going to crush that flat cabling. And while if you do want to use zip ties, keep them very loose so you don't fold that cabling over. Finally, make sure if you're in the United States, you have the voltage selector moved over to the right to 115. If your machine does not power up when you turn it on and plug it in, this is probably the culprit. You still have it on 230. All right, next up, plug the machine in, turn it on. If your LCD comes on, you've correctly assembled your printer. Okay, the next thing we have to do is run the auto bed leveling script. Now, Creality does not tell you to do this, and I've not seen anybody tell you to do this on any of the other YouTube videos I've watched. This is key to getting an accurate measurement of your bed. Before you run the bed leveling script, go into your LCD menu, hit Control, Temperature, and Bed Temp, and crank that up to 65 degrees. Since you're going to measure this for actual printing conditions, the bed should be heated. So it expands in the areas that it's going to expand during a print, and you're getting accurate nozzle readings for that. If you do this on a cold bed, you're not going to get as accurate a reading of the bed mesh as you are if it's heated like in an actual print situation. So do that. Wait for it to properly heat or fully heat to 65 degrees. Then you're going to go into your leveling menu and hit auto leveling. And what's going to happen is it's going to heat the nozzle now. Your bed's already heated. It's going to heat the nozzle, and then it's going to run through at each of these positions. There's 16 of them, and it's going to create a virtual mesh leveling of the bed so it makes adjustments for any deviations in that. And once it's done, that's going to be stored to the memory on the machine, and you're all ready to print. So real quick, before I did my first test print, I did induce a thermal runaway just to verify that thermal runaway protection is on this machine. As you can see here, this pops up on the LCD screen when a thermal runaway is detected. So you do have that protection on this machine. This is a test print I ran with no modifications to the machine. I've not done any tuning on it. I've not adjusted the E-steps or anything like that. This is straight out of the box with eSun PLA Pro Gray and the Fat Dragon Games Cura Miniature profile. I'm running, this was done on Cura 4.6.2. But there you go, straight out of the box, some just exceptionally minor stringing and cutting flow 3 or 4% for this machine, or cutting the E-steps down on the extruder would resolve that in an instant. So this looks really clean. I'm really happy with this. This is as good or better than any of my other Creality machines. And this is with a 0.4 nozzle. If you were to throw a 0.3 or 0.2 on this, it would look, markedly better. Okay, so what do I think of the machine? Well, I've been testing it for a while. So I wanted to hold off doing this video. I really like it. This machine just works flawlessly. Would I buy more? I still think, for me personally, the Ender 3 V2 is the best value on the market. If I'm going to buy some more machines, I would probably buy those, simply because the manual bed leveling doesn't bother me at all. I throw the better springs on. I spend $2 or $3 when I buy the machine on better flat springs, put them on, and once my leveling's done, I don't have to touch it. I maybe run a re-leveling maybe every 3 months just to verify everything's still okay, but the good quality springs will keep it in level without you having to futz with it every other print. That said, this is a great machine, and if you don't want to have to manually level your bed, it is a phenomenal design and a really ingenious setup that they're done with the strain gauges, and I'm very, very impressed with it. The quality is fantastic, and you will not be sorry buying this machine. So that's it. Thanks for watching. Please click that subscribe button in the bottom right hand corner.